This video introduces the deployment of accuracy drift auto-correction in Mech-Vision system. Here, to show the deployment process, use the workstation for picking neatly arranged sheet metal parts as an example. To avoid decreased picking accuracy due to temperature changes, you can deploy an accuracy drift autocorrection feature in the Mech-Vision system, so as to ensure that robots can accurately pick target objects. Meanwhile, the correction cycle can be set to ensure long-term stable picking by robots. Before deployment, make sure the workstation has a vision solution for picking. Confirm that the accuracy of the camera, robot, and extrinsic parameters has been checked, and the robot can accurately pick the target objects. Ensure the space for fastening calibration spheres at this workstation. Now, start the deployment. The process is as follows. Let's begin with the preparation. Check the items for deployment. Open the Mech-Mind kit packaging box, which contains calibration spheres, sphere mounts, and other components. A calibration board is also required as the standard item. The position of the board is used to simulate the layer center position where the target object is located. This will facilitate the subsequent calculation of the locations to fasten spheres. Then, warm up the camera. This prevents the intrinsic parameters from changing due to temperature fluctuations during data acquisition. After this, set the parameter group in Mech-Eye Viewer. Ensure that the 2D image of the calibration board is clear, and the point cloud of the spheres remains smooth and intact. Having prepared, get started with the deployment operation. Open Mech-Vision. Navigate to Toolkit. Click Error Analysis Tool. Click Autocorrect Accuracy Drift in Vision System. Select Mech-Mind. The wizard outlines 4 steps for deployment with the Drift Autocorrection tool. Click Start and begin to collect the workstation data. Connect to the appropriate camera. Select the picking project to be auto-corrected for accuracy drift. Select the corresponding calibration parameter group. Choose the parameter group configured before in Mech-Eye Viewer. Here, select the calibration board as BDB5. Currently, the calibration spheres have not yet been fastened in the workstation, so select Not Fastened. Upon completion, collect the calibration board poses on different target object layers, facilitating the calculation of required calibration sphere image capturing points. In this scenario, the target objects are arranged neatly. Thus, select this. When collecting the calibration board poses, move the robot to the image capturing point above the object layer. This image capturing point must be the same as the one used in the actual production process. Given that there are 2 object layers, collect the calibration board poses twice. Meanwhile, each layer has an image capturing point. For this, move the robot twice to collect board poses. Place the calibration board at the center of the first object layer. Click the Add button to add a layer. Move the robot to the image capturing point of the first layer, and capture the calibration board image. Click Locate. After successful location, the message as shown in the video will appear. Click View Image to check the successfully located calibration board. Then, repeat the above steps. Move the robot to the image capturing point of the second layer and collect the corresponding board pose. After locating the calibration board on object layers, begin to fasten the spheres. Based on the sphere placement and the calibration board location, this step obtains necessary information to calculate the recommended locations for fastening the spheres. The specific operations are as follows. Pre-place the spheres in the space for fastening them at the workstation. Subsequently, place the calibration board. Following the guidance here, ensure that the board is centered among the 3 spheres, and its height remains as level as possible with the center of the sphere. After this, locate the board. Move the robot with the teach pendant to capture the image of the board for location. Click Locate. When the localization succeeds, a message will appear like this. At this point, enter the robot flange pose on the teach pendant into the tool interface. The tool will automatically calculate the recommended image capturing points for the spheres. Then, proceed to fasten the spheres. Here, the robot flange pose with the recommended image capturing point has already calculated. Based on the flange pose, move the robot to the recommended image capturing point. Also, set the sphere diameter. In this video, a 60 mm diameter calibration sphere is used. Click Capture continuously to obtain the recommended locations as shown in the illustration. Adjust the placement of the spheres to the recommended locations. After adjustment, stop capturing. Fasten the spheres as required. Then, click Confirm Fastening. Next, validate the image capturing points. Select the ROI of the calibration spheres at image capturing points, ensuring accurate recognition of the spheres and high repeatability. Based on the board poses collected during the Collect Workstation Data step, the tool calculates 2 image capturing points for spheres here. Both of them need to be validated. Ensure the current robot flange pose matches the recommended one corresponding to the image capturing point 1. Click Outline and validate. Set an effective ROI for each sphere. The ROI should cover the entire sphere, leaving a margin equal to the sphere's diameter on all sides. Then, click Validate. Successful validation is indicated by this message. Repeat the above operation. According to the second recommended flange pose, move the robot to the image capturing point 2 and validate. Once all validations are completed, enable the auto-correction feature to regularly correct the accuracy drift during actual production. Navigate to the project interface. 2 new projects are generated in the list. The first project is used for collecting the sphere's pose data, and the second is for generating the accuracy drift autocorrection model. At this point, a robot program needs to be developed to sequentially trigger these 2 projects, automatically collecting sphere poses and generate an autocorrection model. In order for the picking vision solution to use this autocorrection model for correcting accuracy drift, in the picking project, select Autocorrect Accuracy Drift in Vision System in the Output step. Before starting to develop the program, make sure the project numbers for drift collection eye-in-hand and drift calculation are clearly known. Besides, return to the Accuracy Drift Autocorrection interface. Click Check Deployment to obtain other relevant information required for programming, including the robot flange poses at the image capturing points and the corresponding parameter recipes. This video demonstrates the triggering logic using the development of a FANUC robot program as an example. During the running process, teach home position manually. In this position, ensure that the robot does not block the camera's field of view and that no collisions occur when the robot moves to the first image capturing point. Then, confirm that the IP address and the port number for this command match those used in your real case scenario. Using this program, move the robot to each image capturing point for spheres on different layers. Switch the parameter recipe in the Drift Collection eye-in-hand project. Trigger the project to run to collect the calibration sphere pose data at each image capturing point. After collecting the sphere pose data from all image capturing points, switch the parameter recipe in the drift calculation project and trigger the project to run, generating the autocorrection model. A detailed program example can be found in our documentation. Now, run the drift autocorrection program to test whether the robot has triggered the projects. Go back to the tool interface, and navigate to the data monitoring dashboard. A record of the drift autocorrection will appear. Here, delta x represents the drift compensation for the x value of the calibration sphere pose. The same applies to delta y and delta z. Finally, move on to verify the effectiveness of the deployed drift autocorrection solution. Run the robot picking program. When the robot can accurately pick the objects, the deployment of the accuracy drift autocorrection in Mech-Vision system is proved successful. After testing picking, to ensure the long-term stable operation of the actual production, configure the drift alert threshold here. Normally, the threshold is suggested to be set at 10 mm. If the actual volume exceeds 10, please ensure the camera and gripper are securely mounted, and verify that the robot's 0 point has not been lost. These are all the steps for the deployment of system drift autocorrection in Mech-Vision system. The autocorrection cycle can be set based on the site situations. It is recommended to perform drift correction at least once a day before production. You can refer to our documentation for further details on Mech-Vision system drift autocorrection and the maintenance of calibration spheres. For more information on flexible maintenance after the deployment, please watch our video, Vision System Accuracy Drift Autocorrection, Quick Camera Replacement.